just being a patent lawyer was not my calling. So I just continued with the engineering direction in my career. But the insight of the IP patent laws actually helped me to develop this design for patentability. Why it is interesting for service design, because I know a lot of creative solutions are developed in service design. Companies pay for that, and consultants actually invest a lot of their mental power and creativity developing those, but it does not really become property, because patenting in that field, it just starting, it was not very, and it still is not very popular, partially because people do not realize that they can protect, their developments, and what they developed can become really a property, intellectual property. So in this webinar, I just want to focus on several things. First, I want just very quickly explain the concepts of this design for patentability, just the fundamental philosophy of it. So you will see how it can be used not only to engineering systems, to improvement or development inventions in engineering, but also in service design, because the general approaches are the same. Then I would talk specifically about service design. When I was invited to this webinar, to teach this webinar, I actually looked at my previous practices. Maybe I had done something in that area, and actually it turned out that I actually had done. At that time, it was not called service design, and I just looked at it as improvement of a process. Either it is a process in the bank, or a process in food service, or in other, not exactly technical areas. But again, the philosophy of the flow was exactly the same. So I just pulled out some case studies that I had before that related to service design, just to explain, how this DFP can be used specifically in that field. And also, I would like to mention a couple of other tools, from DFP and TRIZ. TRIZ, by the way, it's also kind of intimately connected with DFP. It is a Russian acronym, because actually it was developed back in the Soviet Union, but it stands for Theory for Inventive Problem Solving. So that's methodology that contains different tools that basically lead people to generating not just engineering or any other ideas, but at the level of invention. And it is based on analysis of the raw patent collection. So basically, due to TRIZ, you can take your problem that you're solving from engineering or from service design, model it in a specific way, and there is like a huge database of models of problems and the models of their inventive solutions. So you just match the model of your problem with the with the model that the database has, and then immediately you get a model of inventive solutions, that derives statistically from analysis of the raw patent collection, and you just grow flesh on that skeleton, and basically you invent according to formula. So I just want to give you some glimpse on that, and there are some tools and actually takeaways. You can take them and use them right away after the workshop. It can be useful, I think. So that's the plan. These three items. But also, if you get specifically interested in one of these three, or have specific questions, just let me know. I can expand it or shorten it. It is like accordion. All right. So this design for patentability Basically, it's a methodology of developing innovative solutions in engineering or in service design or in management. You know, there are a lot of development that is happening there, you know, trying to use the same methods in developing managerial solutions. But, you know, sometimes managerial solutions and service design, they really overlap. All they're like this Russian nested doll. One thing, it sits inside the other. So it is a methodology of coming up with those innovative ideas, innovative solutions. But, you know, some solutions may be innovative, but they, you know, do not satisfy criteria of patentability. That's why you cannot protect them, unfortunately. But using, you know, the roadmaps and the set of tools that DFP has, basically the solution that we will obtain by virtue of the tools that we had used developing them, they will automatically satisfy criteria of patentability. You know, so actually very often we do not really need to make specific efforts, you know, to jump through hoops and find different tricks how to protect them. That's what actually patent lawyers are good with. You know, when it is necessary to protect, they know how to, you know, to do it. Here, everything happens automatically. You know, so we get innovative solutions with pretty high probability that they can be patented. So that is the claim to fame of that design for patentability method. And for small companies and for large corporation, it's very important, because large corporation, they want to protect their investment, you know, in R&D. They do not want those things to be stolen. They want a return of investment of the money they had invested into their R&D efforts. As for startups, you know, those are often robbed, you know, by large corporations, because they do not really realize yet, you know, how valuable their idea is, and they often ignore protecting those things, and actually they lose the rights, they lose sometimes everything. That is why actually protecting ideas and actually getting intellectual property at the startup stage, you know, it's very important. And entrepreneurship also, you know, it's also very important, because it gives huge competitive advantage. Because if you have a patent on an innovative solution in service design or in engineering, basically you have exclusive rights, you know, to use this solution, to get any money from this solution on a certain territory during a certain period of time, for 20 years. It means that you just remove all the competition from your area, you know, where you sell, and you have just exclusivity. That's why, you know, it leads to just significant, you know, sales advantages, and basically increasing the profit that we make. So that's why both small companies and large corporations, they do pay attention. And when we talk about design for patentability, there are several, several types of projects. There are kind of two directions in this DFP. One, it is when we have a solution, engineering or service design solution, you know, and we want to improve. We want to improve our customer service. The bank wants to improve their system of handling complaints. You know, the food service also wants to improve the quality of service, the quality of food, you know, and different aspects, you know, of their customer service part. The second thing, it is so-called IP-centered projects, when a solution has been already developed, but it is protected, it is patented. People are smart. You know, more and more people protect their solutions in engineering. It's traditionally, but more and more in service design. I check the number of patents that companies file, you know, on service design solution. It is growing exponentially. So this is kind of pretty objective data that the area is booming. So, and it is pretty attractive to get that solution that already had been developed and proven and tried, and just embed it into your business. However, if it is patented, you will break the law. You will infringe on someone's patent, and you will, be punished. It's pretty serious, right? Develop from scratch. It is time and money, and there is no guarantee that your solution will be better than the one that the competitor had developed. So this design for patentability, IP-centered projects, they have very elegant way how to work around those competitive patents. And this way, on one hand, you will conceptually have exactly like had been developed, but you do not break the law, you don't infringe, and besides, you don't need to pay money, licensing, or anything. So basically, you piggyback the development of your competitor, and get all the benefits. It's like a win-win approach. What can be better? So DFP can deal with these two sides, in engineering and definitely for service design. What I skipped, actually another kind of aspect that DFP is needed, because it is strongly supported, like all over the world, by patent offices, national patent offices. Here I just mentioned the most active ones, but actually there are many more, patent offices that push it in their countries, that conduct training, initiate training within patent offices and so on. The Swiss patent office is special because Einstein worked there as the patent examiner. Poland is pretty aspiring. In Europe, in Asia, South Korea and China, are pioneering that. So it is just another criteria and another indicator, that it is needed, that it is in demand. And design for patentability, it is a combination of tools from different areas, from different domains, cognitive, engineering, and everything is tied up in quite well-structured roadmaps. Of course, there is patent laws, because there are some aspects of it. We need to know what criteria of patentability there are, so our design is driven towards satisfying those. There is this TRIZ theory for inventive problem solving. We need some creative kind of models of inventive solutions that we would try to use. And of course, some other techniques from value engineering and so on. So it's a composite methodology, but different parts are not eclectic. It's not like a bag with tricks and you fish out one trick after another without any sequence. Everything is tied up in very structured, roadmaps, how to do that. Just 5 minutes. I don't want to spend too much time about some aspect of patents, just legal stuff, and I will do it very simple. So don't worry that we will start talking about something complex. First of all, some things in our life, in our development world, can be patented. Some other things cannot be protected. There are different ways of protection. Of course, there are copyrights, there are authors, right, and so on. But as for intellectual property, things that can be protected, it is, new machines, products, appliances, tools, medical devices, pharmaceutical drugs, etc. Also, technological processes, in manufacturing, for example, different industrial methods as well. I highlighted it as business processes and models. That's why, and methods. That is why service design falls into that, and actually it is protected. Software and some biological material, plants, and so on. Yeah. And things that cannot be protected, artistic creations, theories, some abstract concepts, mathematical algorithms and models, those can be protected by other types of intellectual property, but not by patents. So what can be protected, it's called kind of also it's a criteria of patentability, statutory. So that these things just can be protected according to majority of patent laws. And it was we should be happy that service design area falls into this process and methods. So how can the patent office, the examiner, judge that it is an invention or not? It's just engineering solution or invention? Well, there are these criteria of patentability. First of all, novelty, right? Novelty. It should not be known to the third party, right? It should not be published, known to the third party. That's kind of clear. Usefulness, of course, there should be, some beneficial from that, not just for the sake of inventing. If it does not bring any benefits, it will not be qualified as a patent. And a very serious and difficult criterion, so-called non-obviousness or inventive steps or creativity step. Different patent laws in different countries have different names for that. It basically that this solution should not be all obvious to an average expert in this field. It's very, very fuzzy. But I will explain it much clearer, what it means just a little bit later. And also there are some specifics, in patent law. When we can say that someone infringes my invention, basically it infringes my patent rights, my intellectual property. There may be some issues that I take a competitive patent and just substitute one component with another, hoping that it will not be an infringement. We should be careful with that. And also there are issues when we merge different engineering solutions together, right? For example, there are different systems that when you go shopping in the supermarket, you take products there, and there is a scanner right on the cart that basically scans, and you have you see what money you need to pay, and you can pay right here, on that machine on the cart, so the cashiers are not needed, and so on. So the sales process is much simpler. And then you put those products you bought in your refrigerator, and your refrigerator can also scan that and keep in mind the expiration days and send you email messages that your milk is going to expire, or you need to buy, more fruit, and so on. So if you take these two things and combine them together into a bigger system, one can think that, oh, that is something patentable. Not necessarily, because when you combine things together, sometimes, it is not considered new, right? So two things that I want to mention. One is so-called freedom to operate. For example, look, a wonderful chair on the left, patented, right? And the chair, the claim of the patent says that the chair has legs, seat, frame, and the back. So nice chair, but I have problem moving it around. So I decided to attach the handle, on the back of the seat. And I actually did research and, experiments, and ergonomically through experiments, empirically found that the best place for the handle, that's why I can prove the patent examiner that it is a unique, actually knowledge where to put this handle. And I can get a patent on that. The chair equipped with the handle. I have a patent. I'm a proud owner of the patent. But unfortunately, yes, I have a patent, but I cannot exercise it. Why? Because my solution actually is under the umbrella of a competitive, more general patent. You see, the first patent says seat, legs, back, and the frame, and my includes all these things plus additional handle. But the first patent, it's more general. Everything that has legs, seat, frame, and back, is protected by that patent. That's why I can put a handle, I can attach something else, I can put an armrest, whatever. My solution will still be under the umbrella under the exclusivity of a more general patent. That's why adding new things to someone's invention can give you your own patent, but you cannot exercise it. You will not have freedom to operate. So you should keep that in mind, because many people just think that they take someone's solution, add something additionally, and they have an invention. They may have an invention, but without freedom to operate, they can do nothing with that. The other thing, it is to protect, inventors, from those who want to steal their inventions. Many people want to substitute, for example, the handle with this elastic band. So it's not a handle, it's elastic band, but, I still can pull it and basically do similar things like the handle does. Okay, those things are considered equivalents. And a lot of patent laws have so-called doctrine of equivalence that says that if you substitute one component in someone's invention with another, and that substitution component performs the same function based on the same principle of operation and produces this approximately the same result, that's infringement still. That is why, the patent on the handle protects not only the handle, but all other equivalent solutions. For example, the elastic band, and someone will attach some kind of pendulum, a rope that is just hanging there, is used for pulling the chair. It will be still protected by the patent with a handle. So there are a lot of those details. They're not difficult. You don't need to be a lawyer kind of to understand them, but that's what kind of usually we discuss during training. When people learn how to design patentable things, they need to have some general understanding of these details that belong to patent law, right? But there are rather engineering details, not legal, not really sophisticated from the legal perspective. And hybridization, combining things together. For example, I use it, it's not really real. Well, I thought it wasn't real. I checked and I found that people were thinking about that too. I used to have a very heavy laptop and I carried it with me all the time. It was not convenient. So I thought, what if the laptop had wings and it would just fly after me? I would not need to carry it around. So, for example, I invented the laptop with wings. Can I patent it? Looks like absolutely new, because no one has ever heard and seen laptop with wings. Well, we should be careful about that too, because even cartoons where laptops are flying can be jeopardizing the novelty criterion. But supposedly, the patent examiner had never heard or seen about computers with wings. So novelty is fine, but that non-obviousness criterion that invents a step that I called much more complex. What will happen? The patent examiner will cut off the wings separately and the laptop separately. And the examiner will ask me, look, the laptop without wings, is it a regular laptop or there's something special about it? Regular. And the wings, are they regular wings just to move things or just some very special ones? No, regular wings. So the patent examiner will tell me, so what did you invent? You took two known things that performed their known function, just stuck them together with the summation result. It is not patentable. Did not, make any did not take any creativity step. But if I say, no, Mr. Patent Examiner, or Mrs. Patent Examiner, you did not understand, pay attention. I attached the wings in such a way, when they move the laptop, they also cool the chip. That's why the laptop works better. Or that is some synergetic result. I don't have it in the laptop separately, and I don't have it in the wing separately. Only when I combine them together, that synergetic result transpired. Or then it is patentable. That's why when we do these hybrids, there are ways how to do this cross-linking and find ways how, the resources of father can improve the performance of the mother part of the hybrid, and vice versa. And then we'll automatically get a patentable hybrid. Yeah. So there are many of these nuances. So that's what DFP is. So the design process, how we design, improve devices, processes, methods, well, including service design, and different steps, different phases of the design are furnished with all these guidelines and tools. So what is the most popular right now? Probably it is this competitive patent circumventing. Someone has already spent money and time, a lot of time, invented something. It's so tempting just to steal it, to borrow, well, not to borrow it, but to share, to copy, right? But unfortunately, it is patented. That's why, I will be punished if I just, copy. So getting back to so that's why patent circumvention is popular. So I just want to give you an example of using DFP in that case. Let us get back to our chairs. You see, adding things to someone's patent does not give me freedom to operate. We discussed that. So, but what can give me freedom to operate, what I can use if I remove something, from the competitive patent, not to add, but to remove. You see, the patent says legs, seat, frame, and the back. So what if I remove the frame? No frame. So it means that my solution already does not infringe on this chair, because this chair stipulates there should be a frame, but I don't have a frame. It means I get freedom to operate. I don't know if I can patent it, but at least I get freedom to operate. But you understand that if it is so easy, just remove something, people are not stupid. That's why when they file their application to patents, they include into the claim only those components that are absolutely necessary for functioning. Because so you remove that component and the system does not work. Right. For example, I remove the frame, and after 3 days, the legs basically break, because the frame makes the chair sturdy. It will not work without the frame. So the idea behind patent circumvention through trimming is the following. So basically, you have your engineering system, like the chair with components, or technological processes with operations, or service design. Also, service, it is a process, it's a sequence of operations. Some operations are performed sequentially, some operations are performed parallel. I think within service design, we call it blueprint. When you describe all these services, all these operations, and what is happening within this operation, and so on. So I do this decomposition, determine what functions every component performs, and then remove one of the components to get freedom to operate. But then I will remove some important functions. But no, I take those functions and I delegate them to the remaining components. I will have to solve problems how to enable remaining components to perform the functions of the component that I just trimmed. So that's why I can take in service design, for example, I take some operations from the process, and they are needed. Some functions are performed there, but I remove them, but the functions must be preserved. So I will be looking for innovative solutions. How can other operations take care of those functions, of the operation that I just trimmed? And if I find innovative solutions, on one hand, I have all the kind of benefits of the competitive patent, but I have freedom to operate because one operation was removed. That's why, it is not exactly what that patent claims. So that's the major idea of patent circumvention by trimming. For example, this is a real project from Japan. It's Honda motorcycles. That engineering one, the Honda motorcycles that famous for their sleek design, very elegant design, and they had a problem. The gas tank was too big, too bulky. They made it small. That's why it was very, very nice. But the users complained because they had to refuel the motorcycle very often. So what to do? So they did this decomposition, took the motorcycle, split it into components, and described functions that every component performs. And then, what component gives us headache? The gas tank? All right, let us trim it. Let us throw it away. No gas tank, no headache. But the gas tank performs a function. It contains gasoline. So if I trim the gas tank, other components should take care of that function. Something here, from remaining components must contain gasoline. For example, they trimmed the gas tank and delegated this function to the frame. How can the frame contain gasoline? Well, not much kind of efforts is needed here, right? Let us make the frame hollow. Look at that frame. Is it a frame or is it the gas tank? Both. The frame is designed in such a way that it also performs the function of the gas tank. So basically, that is the idea behind trimming. And what do we get? We get freedom to operate because we removed one of the claimed components. That's why our solution is different. And very often when we're teaching the remaining components to perform the functions that we had delegated to them, we change them, that it gives me some hooks to patent my idea as a separate patent. That's why this competitive patent circumvention through trimming, on one hand, we get freedom to operate, but like a cherry on a cake, we also can patent that idea as our own IP. That is why it is always desirable. All right, you can look at that and say, okay, and where is service design here? Yeah, that's as, for engineering, for components, it's more or less clear. What about service design? Yes, there are different modifications now. It is pretty developed, pretty spread solution. Talking about India, TVS, there's a company, TVS, the motorbikes in India. They are pretty much in this TRIZ and DFP. So where is service design here? Well, here it is. Again, not exactly service design, but it's a technological process. We can actually apply the same thing, as I already mentioned, for technological process. That's another project, that was at Kraft's Food. Maybe you heard it's a big company. Now it's a different name because they merged with other, different food products. In the UK, they have different coffee products and other things. So that was the division that developed mayonnaise and salad dressing and all that. And they have a technological process of making mayonnaise. So they need to mix three things: egg powder, vegetable oil, and vinegar. These are three major ingredients of mayonnaise. And that is the process. So what they do, first, they mix the egg powder and oil and some spices in one mixer. Then this mix, they pump into the second mixer and then they add vinegar. That's how they make mayonnaise. But they change recipes. That is why it is necessary to clean all these mixers and the pipelines when we switch from one recipe to another. And this is quite a pain. They lose productivity. A lot of working hours, production hours are lost. So how to improve that process? We split it into operations, mixing here, then pumping into the second mixer, mixing in the second mixer, and then cleaning here, cleaning here, right? All the operations. And for each operation, we list functions that we perform at those operations. And then we think maybe we can trim an operation, but we preserve the functions from the trimmed operation and just redistribute it among the remaining operations. And that's what they decided. They decided to trim the second mixer, just throw everything together. But they told me it's impossible. Why impossible? Well, because if we do everything together, the vinegar would chemical destroy eggs powder. That's why, the mayonnaise will taste awfully. We cannot mix everything together. That's why we have these two mixers. All right. So we trimmed, one mixing, and that's why we trimmed cleaning, of the pipe and cleaning of the second mixer, during cleaning. But we have an engineering problem to solve. How to mix everything in one mixer so that vinegar would not destroy the egg powder. And here, we use those TRIZ problem-solving techniques. In TRIZ, there is a rule that says if you have two things, two components, and one does something bad to the other, one of the ways to do it, it is, with a field. Introduce counteracting field. You see, vinegar destroys this egg powder with a chemical field. So we need to add counteracting field that would counteract with this chemical one. And there are prompts, what kind of fields we can use. Mechanical, acoustic, thermal, and that's what the solution, counteract the chemical field with thermal. So the idea was freeze the vinegar. It is frozen in cubes, for example, mix everything together. When vinegar is frozen, the contact area with the rest of the mix is very, very small. That is why, first we mix everything together, vinegar is frozen. By the time when the vinegar melts, the egg powder is already covered with the coating of oil. That's why there is no destruction. That's why they had in the past, they had these two stages. First, they mixed the egg powder and oil. So the oil covers the egg powder. And then they mixed everything with vinegar because the egg powder was already protected. But if we use vinegar frozen, then we can mix everything together. So you see, usually this trimming, this approach, it just analyzes the situation and gives me the problem that I need to solve, right? This trimming problem. And after that, we use these tools from TRIZ to come up with innovative idea. But this trimming, in general, in engineering and service design, it is very counterintuitive. That's why people never think about it. As engineers or managers or just any professionals, we were trained how to make things work. So if managerial system is the customer service does not work, my goal is to make it work. Every operation should work. That's why we usually just try to improve what is there. But trimming has a very different approach. It says this part is bad, throw it away. Just redistributes its useful functions among the remaining parts. And you have absolutely new problems to solve. No one had been thinking about how to enable other operations to perform the functions we delegated to them. We created new problems for solving. That's why this approach kind of guarantees innovation. But from IP perspective, it also gives us freedom to operate. That's why on one hand, we get innovative solution. On the other hand, we get freedom to operate. And as we can use it in processes, service design, it's processes. It's steps, it is operations, and there are functions performed at every operation. Some time ago, actually, there was a training, request for training for DFP and TRIZ from Australia. Westpac Corporation, or Westpac Group. So I agreed, but when I started reading what they are, this is a financial institution. It's a bank. And what they wanted to improve the system of handling complaints in the bank. Well, I looked online, what is there? And the only thing I got, how to improve the complaint handling process. Look at these recommendations. Listen attentively, act quickly, keep your promise, follow up. These are very, very general things. They will really shed no light on really how to improve the process. right? So when I went there, there was a procedure that I tried to follow similar to engineering system. So this function analysis of the existing process, like we did with this mayonnaise, with together with the bankers, we split, the process of handling complaints into operations, obtaining customer information, complaint identification, strategy selection, and so on. They had that process already. It just did not work well. It was too long. The complaints were not handled well. They were sent along wrong tracks. So that's why the customers were mad at it, right? They were not informed about this status. So what we did, we just split the existing system into operations, like with the mayonnaise, and we listed functions that are performed at every operation, of course, together with people, because I don't know, I just facilitated. So it's basically through discussions, very much like a lot of things in service design, right? But there should be experts that knew that. And also we kind of attach how long this operation takes, how long each function takes, what functions are performed insufficiently, all this additional kind of data, additional operation. And after that, they all themselves basically suggested to trim some of the operations. But each operation performs function. That's why if I trim this operation, that I need to delegate these functions to some other operations, and that constituted problems to solve. But once this new problem was stated, because they had never had that problem before, right? They generated a bunch of interesting ideas. For example, one of the reasons it was because there were selection of strategies, those tracks along which the complaints of customers were sent, and there were only 5 of them, and the diversity of complaints was much, much bigger. That is why the complaint that did not really belong to that strategy were still pushed down that chute, and those were either lost or, it took a lot of time to handle them and so on. That's why, one of the ideas, they increased the number of those, they kind of segmented those strategies, to be much more precise, for each complaint, and, a lot of other ideas. So that was probably one of the first experiences that I had with, what now I know it is service design. And then, I totally believed that, this DFP and TRIZ could be used not only for engineering, but for service design area. And, when I was invited to this workshop, to talk about DFP for service design, I thought, right, I still need something fresh, because this Westpac Bank, it was, I don't know, 15 years ago. So it is not really a new thing. So, I looked at the resources, and I found, one resource. In Boston, there is a pretty big corporation. Actually, they started as a startup. It is called Toast Corporation. So basically, it is a company that is developing restaurant management processes, restaurant management procedures. And these procedures are also equipped with different software additions to make it more, faster and more precise and so on. So, but they develop not just software, they develop the processes themselves. And I heard about them because they started as a startup, and now they are pretty close to IPO, and valuation is like up to $20 billion. They got an investment, significant one, but now, because they're growing, look, the building is huge there. All this is this Toast company. And why I paid attention to this Toast company. I do this DFP and systematic innovation course at Tufts University. There is a university in Boston, pretty good university called Tufts University, and there is one school, leadership school. So those people are not engineers; they are more like managers. But sometimes they're engineers, sometimes there are financial people. There are different people, and it is a master degree program, and basically teams work in. People work in teams, and they have projects. Sometimes it's engineering projects, sometimes it is managerial projects. And I teach adapt this DFP entries for that course. I teach this subject within this course. And in 2018 there was a group of people, a team from that Toast corporation, and I remembered their project. And their project was about food service. The food service, they said, they wanted to improve it because what happens, for example, fast food service. Just imagine you walk into McDonald's or some other fast food service, and there are menus like on the wall, right? And just over the counter. And you say, look, what is there? And then you tell the person there, the operator, the cashier, what you want, and she puts this data into the machine and so on. More advanced process, included when there was a special monitor for the customer, so you can put whatever your order is yourself. It does not really work very well. It is good only for those that frequent this establishment very often, because when you do it once in a while, just to figure out how this special monitor for customers works, it is not very intuitive. So that group from team from Toast company, Toast Corporation at Tufts University course, they had this project. They were trying to improve, the customer service, basically is the process of, this fast food and their company. So I thought, so that's basically pretty close to service design. So I wonder what happens to their project. So I called them. And it was very timely because they told me happily that they just got a patent, on that project that they started at Tufts. Look, the patent was issued on June 8, 21, just a month ago. Very, very fresh patent. So what they did, they split the operation, they split the process into operations. That's what they did in their Tufts, project. So the customer basically, get informed by the menu. The customer basically makes a selection. The customer informs the cashier, the service person about this choice. The service person puts this data in, and then the food is cooked, whatever. So they split the whole process into operations, and then they decided to trim some of those operations. The operation that introduced the most confusion, right, into all this. And it was working with this separate customer display or explaining the sales assistant what they want and asking many questions and so on. So they trimmed those operations and delegated these functions to the remaining operations. And look what they invented. It is new. That I did not see that solution when during the course. What happens naturally? When you look at these menus, you basically, I did it myself. I point out with my finger, I want this menu, I want this menu, and I want this menu. I literally point out. And they decided to use it as a resource. So basically, it's like a smart display menu. It tracks at what you point, and basically, that generate the information. That is the choice. So that is why there is no extra steps, extra operations, communicating with this separate monitor or communicating with the sales assistant, right? So basically you point and the information goes there, and the process is much, much, much faster. You can do it without really speaking the language, right? You can read, of course, but you don't need to say anything, right? And they just got this patent, and they're implementing it. They have different. They have this fast service, fast food. They have kind of fine dining, you know, and there are some claims in their patent about, you know, fine dining when people are sitting at the chairs. Also, you know, there are some innovative ideas, right? So basically the whole, and of course, attached to this process, they are developing a software that can do that, and devices that they can sell, right? But basically, you know, they analyze the process, basically food selling process, food service, you know, process, and they just trimmed some of those operations that were the most problematic. They took the most of the time, most of confusion, and they trimmed them, and they stated a problem. How can the menu not only inform, you know, the user of the choices, but also take the orders? How can the user inform the menu what they want? And the shop assistant and other monitors were just trimmed. They were just excluded, you know, from the process. I told you I looked at other patents, and I noticed that Fujitsu, you know, they patenting. I did it only in the US. This patent search, they patent a lot, you know, in what basically we can call it service design. So look at the invention, customer service managing method. Right. So basically, it is a process. It is step-by-step process. You know, how they manage, how they treat customers. You know, they, you know, call a specialized clerk, and that clerk, you know, does something with the customer, passes the information somewhere else. So if you look at the claim, basically it says, you know, step-by-step procedure. You know, customer service managing method that includes identifying clerk to perform customer service from among plurality of clerks based on customer service request, and blah, blah, blah. So just step-by-step process how customer service is performed. That's what they're patenting, right? And of course, you know, there's a block diagram. You know, basically this is like a blueprint, inventive blueprint, you know, how it is done. And definitely those parts that can be computerized, you know, they also patent these specific devices that can do it, right? Because it is usually in service design, there are managerial steps, but also there are some, you know, digitalization and computerization if possible, because that is the product that you can sell. Because I did not mention that there is one drawback with patenting processes in general, including service design. It's very difficult to track that your invention is infringed, because for technological processes, it's extremely difficult, because to understand that someone is using your technological process, you need to get to the factory, you know, to see that, because looking at the product, you cannot really know how the product was made, right? You do not have control of that process. That's why some companies, they prefer even not to patent the technological processes, because it's very difficult to track if they were infringed or not. That is why, you know, if you actually develop software that follows your invented process, the software, it is a product. That's how you can track that someone is infringing, and there is a proof, and so on, so on. That is why both processes in engineering and in service design, you know, I saw it with food services, and with this customer support management method, you know, from Fujitsu, you know, together with developing the method They also tried to equip it with specific software on some computerization and digitalization products, right? Because otherwise there is this drawback that it would be very difficult to understand that your invention was infringed. You need to be present there to see how the process is exercised, but they will not let you in there, right? Everything goes backstage. That's why you do not know. A little bit about some other things. And I have never done that for service design, but it worked wonderfully for supply chains. But if you compare service design and supply chain, in a way, there's a different scale, but in a way, service design also has different stakeholders. There is a customer, there are different service providers. And on one hand, they want to satisfy the customer. On the other hand, service providers also should not be victims, of an ugly process. So they want to both to improve the process for purposes of serving the customer better, customer-centered, as they say, right? But at the same time, it would be nice to improve the productivity and efficiency and time, of the functions that the service people, the people that provided service actually perform. So in a way, it's also like a supply chain. There are different stakeholders there, like in supply chain, different stakeholders in service design. I looked through some article, actually, they call them like stakeholders, even in service design. So, so what they did, this DFP and TRIZ methodology for in these situations. First of all, each stakeholder has very important criteria, very important parameters that are important for these specific stakeholders. In innovation domain, they are usually called main parameters of value. Sometimes people mix it with voice of the customer, because that's what the customer wants. It is not really exactly this, because customer, I'm sure you deal with a voice of the customer too in service design, if it is customer-centered service design. Customer asks for very many things, but when it comes to paying, customer is not ready to pay for all of that. They want it, but they want it for free, but we cannot do it for free. And when it comes to paying for these things on the, from the voice of the customer, they are not ready. They will not pay. That's why, we can create a wonderful service and go bankrupt, because, we will not get the return, on that wonderful service. So this part of voice of the customer that really influence purchasing decision, that customers are really seriously ready to pay, they are called main parameters of value. And every stakeholders, in the service and the end customers, they have their own MPVs, right? People that do manufacture, that create something, those that do storage, those that do transportations, those that do distribution, whatever, they have different MPVs, different important parameters. And these MPVs, they may be described at different levels. Usually, that's what marketing people say. They are similar to very different products. Everyone wants to low cost. Everyone wants convenience to use. Everyone wants health and safety and sustainability and manufacturability. So that's, kind of very, very high level of those needs of those MPVs. But for every specific project, each of these may mean totally different. For example, if we talk about convenience for communication area, convenience split into many smaller, more detailed requirements. Convenience for communication area mean operator availability and self-dial and installation coverage and many other things. And each of these in its purpose also depends on some smaller kind of things. So what is done within DFP and TRIZ? Basically these kind of MPVs, whatever every stakeholder needs, they are described at high level, and then the second kind of tier, like we did for convenience, that was kind of the strategic MPV. For communication area, it is these, and each of these up to operator ability. What does that depend? There will be several kind of other things. So if we take this, describe this needs, on a high level, and then more and more granular, in the end, we will have a lot of very small things that we need to improve, really, really teeny tiny. And this is easy, and, there are very narrow experts that know how to do that. So because to improve something at that high level of the need, it's very difficult because we don't know what to do. It is like those recommendations for banks, for handling the complaint system. Discuss, act quickly, keep your promise. How? Because I try, but it does not work. That's why we need to go very granular. And that's what this methodology, we can split these MPVs from every stakeholder, into much more granular things, like this. And it is much, much easier to address them. But there is also another thing, that is something that was done for Alcoa, Aluminum Company of America. They wanted to use aluminum for making the cases for laptops. So these are like supply chain. There are different stakeholders, in their supply chain, like different stakeholders in your service, process. And we can, what we did, we described, MPVs, important things for every stakeholder of the service or of the supply chain, right? And what we can find here, some MPV, some things are important for many stakeholders. For example, end user for the laptop, they want different things, and they want laptop to be cool because very often they keep the laptop on the laps. And if the laptop gets hot, it really can make you very uncomfortable, almost kind of, burning your laps. And other stakeholders also worry about temperature because laptops become thin, a lot of components are cramped into a small space. There is no way to cool it down. Right? That's why cooling these thin laptops is very important. So my point is that when we described MPVs of different stakeholders, we can see that there are some parameters very important for every stakeholder. So we should pay attention. That is the priority, because each stakeholder of our service needs that. That's a parameter that must be improved there. So we will kind of focus on that. But in addition to that, we can get some other information, because some MPVs, some MPVs can contradict. For example, yes, I want good cooling. I want to have low temperature, but for that, I need to have a lot of space between components, and then laptop becomes thick. But it is now must be thin, because that's another MPV. So we have so-called contradictions between or among MPVs for one stakeholder, but also there may be contradictions among MPVs of different stakeholders. And that's what basically makes the whole process very ineffective and slow and not that good. And it's very important to realize, to understand, to formulate these contradictions among MPVs within stakeholder, or contradictions, for different stakeholders. Why is that? Because in TRIZ has all the wonderful inventive tools how to resolve these contradictions. That's one of the most known tools in TRIZ, because this situation, this contradiction of MPVs, contradiction of parameters, it's typical in engineering too. I want my table to be 10 times stronger because it's kind of flimsy. I know how to do it. I'm a mechanical engineer. I can make it thick. It will be strong, but it become heavy. So my table will be strong, but heavy. All right, and trees has different tools. For example, this contradiction matrix, the vertical axis of the matrix, it's parameter I want to improve and horizontal parameter that can deteriorate. So I choose strength because I want to improve strength of the table, as improving parameter, and weight of the table as worsening parameter. And this matrix gives me so-called inventive principles, the recommendations that derive from analysis of the raw patent collection. Many inventive solutions in engineering and management, they were obtained using these inventive principles. These are the names, but also they are described more granular. So if I found these contradiction, in the operation of my service, within same stakeholder or contradictions of different stakeholders, I can find inventive solution. For example, in food service, I need a lot of servers, a lot of waiters to serve my clients fast. But you know what? If it is fine dining, it's a very nice ambiance, and I don't want to have 100 of those servers, moving around, and serving other customers. I want to have a nice, quiet evening with candlelight and everything, right? And I don't want to have a crowd of bustling servers around me. So I need a lot of servers, to serve customers very fast, but, it will break the whole ambiance, the whole experience of fine dining. Oh, a contradiction. And I can stick that contradiction into the matrix and get recommended inventive principles. This is engineering matrix, but there is a matrix also for business. Here we will have parameters, not engineering parameters, but business parameters, right? And there is a list of those inventive principles with detailed description. And this list also, these inventive principles are explained not only for engineering, but for business and for IT, for different areas. And that will help to resolve the contradictions very inventively, right? So that is why, on one hand, TRIZ and DFP have tools, but these describing MPVs of different stakeholders and identifying contradictions, with these MPVs, resolving them, it will streamline the whole service of ours, right? So there are some other things, not only kind of strictly speaking, just patenting, right? But again, still it's connected because these are inventive principles. The idea is how to resolve this contradiction, to have many servers to serve people faster and to have few servers, not to break the ambiance of fine dining. If I find a solution, inventive solution, how to do it, as we discussed, it can be patented, as a process, right? As a business process in service design. So that's why, there are both analytical tools that can find those new problems to address and problem-solving techniques that can bring us, help us to generate inventive ideas. And after that, we patent them, right? Or we can circumvent competitive patents. So it is just, just an hour and a half, just scratching the surface. I wish I could talk more. Well, I see some participants, just because I also teach that thing in Tongji University in China. This is a very, the Katerini is here, she graduated this program a couple of years ago. That's a program funded by WIPO, World Intellectual Property Organization. There's a specialized agency of the United Nations, and it has this subject there in this master degree program. So she knows more about that. She studied, she's from Greece, so she's an entrepreneur and IP person, IP expert. I see her on the screen, right? So, and the last thing, and I will be done. When I have these different operations, right, or different stakeholders, and I did kind of function analysis, I described functions that every operation, that I performed at every operation, what I can see that some functions are repetitive. I do it again at every operation. What does it mean? Maybe it is not a good idea to do it again at every operation. Maybe I can find one operation where it can be done the best and actually, do it there if it is possible. Some functions can be contradictory. Here, we cut food or whatever and package it, cover with the film and everything. But at another operation, someone has to take that film away because now I need to add sauce and some other things. So if I see those contradictory functions, maybe, it will also streamline my service, my process, because I don't need to do and undo at the following, operations, right? So we can give you some ideas how to deal with that. And sequential functions, if, one follows another, maybe it also makes sense to combine that with one stakeholder, within one operation. So this understanding of repetitive, contradictory, and sequential functions also will give me some ideas about streamlining my process, right? So there are other tools that could be used for service of design. I had never used it. I just looked at, possibilities, right? The only thing I used really, it is as I said, walking around competitive petting or improving the process in banks or food service. That was pretty much like service design. But when I looked how to extend that, actually DFP and TRIZ has many more tools that could be used, right? Okay, well, because it is the Indian chapter is organizing it. I just named several companies that are the most active in India with this DFP. They trained many people inside, but of course, these are engineering companies. Honeywell in Gorgon and Sabic, it is in Bangalore, and TVS, as I already told you, in Bangalore, but some others. So that's that's it. Sorry, it was like a marathon because I wanted to squeeze as much as I could into that. If you are interested, I can send you these matrices, this contradiction matrix for engineering, for IP, for management, when you put what you want to improve and what deteriorates, and you will get recommended inventive principles, to brainstorm at least around, and I will send you the description of those principles. That those files are available. I will be happy to send them to you if you are interested. It may be like a takeaway because those are not difficult tools. Just drop me an email and I will be happy to send them to you. Specifically management and IT contradiction matrices.
Yes, Dr. Sergei, definitely the management in IT would be of great interest to service designers. So it would be great if you would share that with us.
Sure.
Thank you so much for this wonderful session. As a practitioner, I definitely see there is a lot of synergies that we can learn from, DFP and work towards patenting the solutions that we build for our clients or for our own organizations. Because in today's time, we all know innovation doesn't happen that easily. It takes a lot of time, effort, money, the right set of brains to work on it. And it's also equally important that the effort that an organization has put in is protected for whatever period, so that it doesn't get easily copied. So it's very important. Thank you so much. Now I would request if participants have any questions for Dr. Sergei, please unmute yourself and feel free to ask any questions that you have. Bridget, would you like to share your thoughts?
If I may jump in with a question.
Sure, Manu.
Yeah, so I found the matrices you were using to be like a revelation in terms of like innovation and stuff. I didn't realize this the stuff existed outside of the parameters of service design and innovation within service design in other fields. Are there any other mental models or structures or frames like that that you like to go to, and how have you successfully used them in the past? Thank you.
Right, thank you. Again, these TRIZ and DFP, they have basically dealt with models. And the stress theory for inventive problem. So basically, if you have a problem to solve, the problem should be very well defined. You know, there are special ways how you model it. And then there are kind of specific recommendation how to process this model. And in the end, you get a model of a solution. Like with this mayonnaise, you said, okay, you need to introduce a field that counteracts the chemical harmful field. And these are the fields that you should consider. They consider thermal field. Okay, so from here, it is quite easy to come up, well, let me freeze it, right? Once we identified the problem we want to solve, after that, there are models, and there is a quite clear way how to process the models and get model of the innovative or inventive solution with the mayonnaise, or with the management system. It does matter. And also there is this number of things. I just showed only one, that is kind of function analysis. When you split your service, right, into operations or whatever you call. And, I looked through some articles in service design, they usually call it blueprints, different types of blueprints and so on. But it's pretty much like what we call function analysis, right? And also there are different techniques, and there are kind of some modeling things that we use in this analytical part, to in the long run to come up with the problem that we want to solve. You see, the issue with innovation or invention is that if we jump at a problem that we see on the surface and try to solve it, most likely we will not be very successful. Because if this problem exists, other people know it, and other people try to solve it. And if they did not solve it, being experts in the field, it means that's a difficult problem. Let us not be too presumptuous and think that we're smarter than others. It means that probably we will not be able to solve this problem brilliantly as well. But the secret of innovation is you substitute the problem that you are solving. You actually, instead of that problem, that other people are addressing, you find another problem through which you can achieve the same project goal. That's our mental block. We think that, okay, to achieve that goal, I need to solve this problem. That is wrong. We need to achieve the project goal, and we can achieve it through solving the whole bunch of different problems, and we need to choose the easiest one. And in DFP and TRIZ, there are tools how to find the easiest problem through which you can achieve the project goal. That's where the strongest side of TRIZ and DFP is, that it's a game changer. We substitute the problem that usually was addressed to achieve that project goal with another problem through which we can achieve the same goal, but that problem is much easier to resolve. And yes, the DFP and TRIZ, it has a bunch of those game changers.
Any other questions from any of the other participants?
If there are no other questions, may I jump in again? Sorry.
Sure.
Thank you for the last answer. Have you ever incorporated concepts from biomimicry, or are you familiar with concepts?
Of course. It's not only biomimicry. Very often it is partially engineering, but sometimes maybe not necessarily engineering problem. So basically, once we formulate a problem, it's about performing a function. We need to find, it's better to find a technology that knows how to perform this function. And this technology that you are looking for, of course you can invent it from scratch, but it will take a lot of time. It's better to find maybe something like that already existed in other areas. So it's better to take it from there and adapt it, for your field, like you say, biomimicry. So, and there are different areas to look for. Nature and biology, it's only one of them, right? But not only mimicry. For example, we had a project, I live in Boston, and not far in Connecticut, there is a very, very big Unilever facility, R&D facility, skincare. And they are making products that change the creams that change the tone of the skin. Some people want their skin to be whiter. Some people want their skin to be a little bit darker, because if the skin is very white, it's very uncomfortable, it's irritable, rashes and all that. So they were looking for different methods, for different technologies, how to make skin whiter a little bit. And there is a special tool that's called function-oriented search. We need to look in the area where this function is like matter of life and death. If they don't know how to do it there, someone will die or the product will never come to the market. And nature, it's not really biomimicry, nature is one of the recommended areas. So they were thinking in what area, it's absolutely critical to be white. If some plant or animal is not white, this plant or animal will die. And during brainstorming, they thought polar bears. Polar bears, they must be white, because if they're not white, just imagine polar bear being black. He will be visible on the snow for miles around. He will not be able to hunt. He will starve. So he must be white to disguise himself. Very nice. Good. Do you know what is the skin color of polar bears? Huh? Anyone know? Skin color of polar bears?
I'm gonna guess pink, something like that.
You have never shaven a polar bear? I'm shocked. No, if you shave a polar bear, his skin is charcoal black. Yeah. It's very cold there. They developed the black skin to absorb all infrared they could. The skin is charcoal black. What about fur? What about hair? Huh? What is the color of the hair? It turned out that the hair is translucent, transparent. It's optical fibers. Look how interesting. Optical fibers on a darker substrate look white. And there is not a single white thing about the polar bear. His skin is black and his fur is translucent, but he looks white. Look, what an interesting invention polar bears made, and they never patented it. But Unilever now patented. What did they patent? Cream. You put it on the skin, on the face, and it creates nano-optical fibers on the skin, and the skin becomes visibly lighter. The same effect, the same result like polar bear's head. You see, so there are mechanisms that allow to find, these different technologies. This is technical one, but also the same thing can be in management, right? Maybe there is some managerial methods that we used in, I don't know, in car sales, and we will use them in food service, in a totally different domain. Just we need to adapt them. Yeah, there are tools there.
Okay, there is a question in the chat. Do you think FOS can be used in service design? And Trizit says FOS means a similar function exists in different industry.
Yeah, right. That's a good question. We need exactly the same function? No, right. If they carry around food, like the servers, the waiters, yeah, they carry food only in service industry. That is why to use as FOS, function-oriented search, we need to generalize our function, because if it is very, very specific, we will never get out of our specific domain. But if we generalize it, okay, then we can find some methods, right? For example, servers, in a way, it's a distribution. How do they do logistics and do distribution systems, among different warehouses and so on? So we need to generalize this this function. Yeah. So that's why it is not that exactly the same function, but there are special steps how we generalize. We generalize